Now we are ready to see the Arduino Uno board. If you have the board with you, take it out and have a look, otherwise just follow this tutorial. This series of Arduino tutorials uses Tinkercad, which is a suite of design and simulation tools. One of the things you can do with Tinkercad is simulate circuits and circuit components. So first, let's get the Arduino out. This is the Arduino Uno board. Let's have a closer look. So first here we have a USB connector. This is how we will transfer all the code across. Whatever programs you wish to write, whenever you want to upload them, you'll connect it here. This is the power connector. You don't need this power connector if you are powering it through USB, but if you do not wish to connect it through USB, you can always use this. You can also power it using this V-in port over here. So here are some pins over here and some pins over here. So these are digital pins. These 13 digital pins over here. What this means is that they will take in a digital input that is in the form of a 1 or a 0, and they will give a digital output again in the form of a 1 or a 0, a time varying signal of 1s and 0s. These are analog input pins. What this means is that they can take a continuous input. It need not just be a 1 or a 0, a time varying signal of 1s and 0s. No, it can have continuous values, and there are some limitations on it, but yes, it isn't just a high or a low that they can take in. Now some pins are marked here with this PWM thing, this little line here. What this means is that they can also give something similar to analog, an analog output. It's not true analog, and if you ask an electrical engineer or an ECE, electronics and communications engineer, then they will say that this is not an analog signal, but for the purposes of this tutorial, you can assume it to be analog. Right. So they can give an analog output. So these pins can take a digital input, give a digital output, and some of them can give an analog output. These pins take in an analog input. We also have some ground pins. This is a ground pin, this is a ground pin, and this is a ground pin. This is a 5-volt pin, meaning it gives a constant potential of 5 volts. If you connect something to 5 volts and you connect it to ground, that device will have a potential difference of 5 volts across it. Here we have a 3.3 volt pin, we have a reset pin, and we have some other pins, not necessary for this tutorial here. At the heart of the Arduino board is this here. This is the 80 mega 328p microcontroller. So we've all heard of microprocessors like the Intel i3, i5, i7. Those microprocessors are very powerful and very versatile, but they cannot function independently because RAM, ROM and peripherals are not built in. By peripherals, I mean the ports or pins to which we can connect external devices. A microcontroller, on the other hand, includes all these things. It has built-in RAM, it has built-in ROM, it has various ports built into it which we can use, various pins. And you can find microcontrollers everywhere. You can find them in refrigerators, washing machines, microwaves, cars, basically any electric device which needs some sensors or some external inputs probably has a microcontroller. So if this has everything within it, what's all this then? The rest of the board. What the Arduino platform does is that it makes this microcontroller easy to use. We can connect it to a computer through USB and power it with the same thing, or we can use an AC to DC adapter. There is an easy way to program this microcontroller and to upload the code. And the number of sensors and devices which support the Arduino platform is very large. And that makes it ideal for DIY electronics. Okay, let's power an LED using this. The first thing we need is a breadboard. This is a breadboard. This right here. This breadboard has some lines, some dots arranged in lines. So what you can do is you can connect your components to this breadboard instead of soldering them together. So every line over here, like this line of pins, is at the same potential always. It's like an exposed copper wire that's running underneath. This line here is one exposed copper wire. This line over here is another copper wire. This here is one copper wire. So here you have two lines where you traditionally connect your voltage source and the ground, of course. Here you have these vertical lines where traditionally you connect the devices. So if I connect a 5 volt line here and the ground here, and I put a bulb, let's say, between these two, then the bulb will have a potential difference of 5 volts across itself. So let's do that now. Let's say I have the 5 volt line. I connect it here. What's at the bottom is the same as what's at the top. This is one line and this is another line. Now let's say I connect a ground. Now I have connected a ground and let's take this up. So let's say I connect this. Now I wish to connect an LED. Cathode. One thing, if you have a physical LED with you, the long end is connected to positive. It's not connected to this line yet because I wish to add a resistor. So this line over here is different from this line over here. So now I put this resistor and I connect this over here. Now let's see what happens. It is running and the bulb is glowing and it's glowing constantly. Pretty neat, but not what we are looking for. Not all that we are looking for. We wish to do more. Let's say we want to make this bulb blink. So what I can do is connect this to one of the pins here. Let's say pin 11. So what I have to do is set this pin 11 as an output pin because I wish to give some signal from pin 11 to the LED. By signal I mean any variation in voltage. In this case it will be a digital signal, meaning I will set it high for some time and then I will set it low for some time. Don't worry if this doesn't make sense just yet, I'll walk you through the code. So now let's program this. This is the way the connections are. I have a connection from pin 11 to the breadboard, to one of the lines of the breadboard. I have a resistor from one line of the breadboard to the other line. To the second line I connect an LED from one line to the third line. From this line I connect it through whichever way I want to the ground. I could have just, I don't need so many connections here. I could have just deleted this wire. I could delete this wire. I could delete this wire. And I could connect it directly to the ground. Okay, it's the same thing. So let's code it first. So there are two parts to it. There's a setup and there's a loop. So the setup function is what runs once, which is where we put all our setup code. The loop is where our main code is, and that is the one which runs forever. So the loop runs forever, setup runs just once at the beginning of the program execution. So the first thing we need to do is set pin 11 as an output pin. So pin mode 11, output. Now here, this loop will run forever. I wish to make the LED blink, with the blinking being like for 500 milliseconds it will be on, for 500 milliseconds it will be off. So digital write 11, high. So what it does is it sets pin 11 at a high voltage, somewhere around 5 volts. I wait for half a second, 500 milliseconds. I set pin 11 to low and I wait for half a second. There's an error. And that's what happens. Now here I have the same thing, exactly the same thing, except it is on the physical board. So I have a ground pin which is connected here. I have the negative terminal of the bulb connected. I don't know if you can see this clearly. I have the positive terminal. I have a resistor which is going across lines, and I have this going to pin 11. Now let's go to the Arduino web editor, create a sketch and type the same thing out. Now if I connect, yes, now if I upload this, this is the result, uniform blinking. So suppose I change the delay to 1000 at one end and 500 at the other end. Let's make it a little more obvious. And if I do this, right. So that's how digital write works. So you have seen setup, you have seen loop, you have seen pin mode, you've seen digital write, and you've seen delay. This is how a binary counter works. It is counting the numbers from 0 up to 2 power n minus 1, here n being 4. So it's counting from 0 to 15. With all the knowledge of C syntax that you have and the know-how of how to make a pin light up and turn off, you should be able to make your own binary counter. So that's the first assignment. It should look something like this. Try to make one which works for 5 pins, that is 5 LEDs. So we've managed to get this LED blinking. Now this LED, we have managed to get it blinking in a very digital way, meaning on and off. We can make this LED blink in a much smoother way using analog write. So I've declared here a global variable, that's fine for this small program over here. Try not to do it in larger programs in C. With Arduino we are more concerned with saving memory. So now I also need another one, int n is equal to 0. So what I can do is analog write 11, n. If n plus step greater than 255 or n plus step less than 0, step is equal to minus step, n is equal to n plus step, delay 100. Let's see if this works. Yes, it works, but it's a little slow. So let's make delay 10. Stop the simulation. Delay 10. So if I make step 1, delay 20. Let's see this on the board itself. As you can see, it is running smoothly. And the bulb's brightness is now changing smoothly. Instead of just turning on and turning off, it's going through a variety of steps. It's going through a whole range of steps from 0 to 255. So now we can understand analog write. So analog write is another function. The first parameter is the pin number. The second parameter is the level. Here the signal will be proportional to this. We can put a parameter from 0 to 255. That's the value of the argument, from 0 to 255. So what we're doing here is we have a step here predefined. We have an integer n. We write n, the analog signal of n, to this. Now if the step is going beyond 255 or beyond 0, make it its own negative or additive inverse. Just step is equal to minus step, then you add step to n with a delay of 5 milliseconds. So what that does is, n is 0, it keeps increasing until it reaches 255, then it starts decreasing. So that's what happens, n increases linearly first, then decreases linearly. Your second assignment is to make something which behaves like this. Not exactly like this, but similar to this. Just freak out, do whatever your imagination tells you to do. But it should include analog write as one of the ways of turning the bulbs on and off.